right, guys. So the next unit or the next topic that we're going to be going through in this 6 weeks is systems of equations. Now, a system of equations, let me highlight this. A system of equations is basically where your graph or where you have two or more lines on the same coordinate plane. There are several different ways to solve a system of equations, or to find the answer to a system of equations, to find the solution to a system of equations. But today we're going to be practicing doing this by graphing. That's why it says graphing systems of equations. So a system is two or more lines on the same coordinate plane. Two or more lines on the same coordinate plane. Now think about it. If you were to graph two lines, how would they look? It would actually look one of three ways. That's the ugliest star I've ever drawn, but that's okay. It would look one of three ways. So let's look at the first option. The first option that we have here is one solution. This is what happens whenever the slopes are different. The y-intercepts, they may or may not be the same. But when graphed, the two lines will intersect. They will intersect, or they will cross one another, meaning that there is one point, one ordered pair where they intersect, so there is one solution. Now, when you're solving these, or when you're graphing these equations, remember, always very important to remember that your equations are solved. Make sure equations are solved. Make sure your equations are solved. Let me zoom in, just in case some of you are watching this on a phone. Okay, so let's graph these two equations. Notice how we have y equals on both of them. So they're both already solved. We don't have to worry about that part this time. My y-intercept is -2. Remember, you can't leave a whole number. You got to put it over 1. And my slope is -2. Sorry, I had a moment. And then my y-intercept is -3. Got to label the y and the x-axis. Okay, so we start at the -3. We have a -2 slope, so that means down 2, right 1. I don't want to go down too far because I want you guys to be able to see the whatchamacallit. Now, since I can't fit any more points, the opposite of going down to the right, up to the left. Up to left 1. Once you're done, always connect and extend your line. Ooh. Connect and extend your line. And then let's graph the next one. We have y is equal to 2x plus 1. So my slope is 2. Can't leave it as a whole number. Got to put it over 1. My y-intercept is 1. So I'm going to start at the 1. This time we have a positive slope, so up 2 over 1, up 2 over 1. Opposite of going up to the right, it's down to the left. And we notice that we end up sharing one point. Okay. Now that point, this point that is shared, that is what we call our solution to the system. This is our solution. Our answer. Remember, solution is just another word for saying the answer. The solution to the system. Now, When you're given the solution to the system by graphing, you just give it as an ordered pair, -1, -1, -1, -1. So that is the answer. That is the solution to this system, to this pair of lines. Okay? Let's look at the next example. The next example is where we graph two lines and they don't cross. There is no solution. Okay? So when there is no solution, that means that the slopes are the same. And thinking back to what we worked on last week, the y-intercepts are different. When you have the same slope, what does that mean? That the two lines are parallel. And since parallel lines don't cross, there is no point where they intersect or cross. That means there is no solution. So let's graph these two lines and see how that would look. Starting with the first one, my slope is +2/1. My y-intercept is -3. Here's my y, here's my x. So I'm going to plot the -3. +2, so up 2/1, up 2/1, up 2/1, and so forth, down 2/1. Connect your points. Okay. Let's plot the next one. Actually, I'm going to do it in pink. My slope, 2/1. Notice they have the same slope. My y-intercept, let me make this bigger because it's getting on my nerves, sorry. My y-intercept is 1. So y-intercept is a +1 this time. Same direction, up 2/1, up 2/1. Then opposite of up to the right, down to the left. Grab those points, connect. And notice how these lines do not intersect. That means there is no solution. I'm just going to write that in little quotation marks or something. No solution. There is no solution to this system because they are parallel. And the last option, infinite solutions. You will come across an infinite solution when, here we go, when the slopes are the same, the y-intercepts are the same. So if the slopes are the same and the y-intercept is the same, when graphed, there is only one solution. There is only one line because these slopes are, the slopes are the same, the y-intercept is the same. There's only one line, meaning it's the same line. When you have the same exact line or two lines on top of each other, there are infinite. I can't spell infinite today. Infinite solutions, meaning they're crossing at multiple points, and we will see that here when we graph it. So let's graph the first one. Notice how it's already solved for y, so let's start with my slope. Slope is 2/1. My y-intercept is 1, so I'm going to plot the 1, 2/1, up 2/1, up 2/1, opposite of down to the, up to the right is down to the left. So I have my line. Let's plot it. Oops. Okay. Moving on to pink. Now remember, all of your equations have to be solved for y. So the opposite of -2x is adding that 2x plus 2x. When I bring down y, I notice it's by itself. So I'm ready to graph. 2/1. My y-intercept is 1. Y-intercept is 1, so that point is going to overlap this one. If I go up 2/1, it overlaps this point. I go up 2/1, it overlaps this one. If I can't go up to the right, I can go down to the left. Overlaps, overlaps, overlaps. That means if this graph were bigger, we would be overlapping an infinite number of times, meaning there's the same line, one on top of the other. Ooh, I thought it would highlight the line. So we have infinite solutions. One line on top of the other, infinite solutions. And that's it for the video for today. We will be doing some additional problems before you guys get started on your homework. Have a great day.